In this video, we're just going to go through a bunch of constructions that we learned throughout the course of the year, following along with our Geometry Constructions review packet. Okay, so starting off with one of the first constructions we learned is just how to copy a segment. Now you have your steps all listed out over here. Draw an arc of circle CA with radius AB. You're going to take that arc and copy it onto the line, and say we want to make it twice the length, we just have to do the process twice. Okay, so what all these steps are saying is that you're going to start by putting the pointy part of your compass at the end at A. And you're going to open up your pencil so that it's as long as B. So you're copying AB here. So I'm going to take my pencil, make a copy mark. I'm going to pick up my compass, not changing the measurement, and put it at the end point of the segment I want to copy it on. So on this ray, P. Make an arc. Now what I've just done, and I'll call this C here according to the directions, by calling it C, this segment here, PC, is the same length as AB. But I want to construct something so that it's twice the length. So if I grab my compass again, I'm going to put the compass where I left off, in there, make another arc. So now this endpoint, or this segment, this little endpoint right here, I'll call D. So PD is equal to twice AB. And that's copying a segment. So if you want to do this, say, and make it 3 times or more the length, all you have to do is just repeat this process multiple times. So if I go up and grab my compass, okay, so like say 3 times, I'll start at the end of this dashed line here. This would be 1, 2, 3. Okay, so this endpoint down here to the endpoint I left off, this is now 3 times the length of my original segment AB. Okay, say your task is now to construct an angle congruent to a given angle. So this over here is my congruent angle. Okay, so following my steps, I'm going to draw a circle with the center at A, any radius. So I just got to get my pointy part right in there. And then I'm going to construct an arc. And this radius is as good as any. So this is part of the circle where the center is at A. I'm going to label the intersection points B and C. And then what we're going to do is draw a circle CP with the same radius as CA. So picking up my compass again, now notice I haven't changed the measurement. I'm going to put it back at P. And I'm going to then construct a circle, or a pretty big arc really. Like that. I'm going to label the point of intersection between the circle and the line as D. And then I'm going to go back up to point C here and construct a circle with the radius CB. Okay, so let me just twirl this a little bit. Okay, so there we are. And construct our circle, okay, or an arc. I'm going to take the same circle or arc and I'm going to go back now to our center D, or our point D. That would be the center of the circle. And I'm going to construct an arc. Now you see this intersection point that they've gotten to, and this little intersection point right in here. We're going to label that E. So from P through E, if we construct a line or a ray here, I'll just use my line tool. This angle that I've created is now congruent to the original angle. So we did it. Okay, so that's it. Okay, what if we want to construct the bisector of an angle? That means we're going to split it exactly in half. Okay, it starts out the same way as the previous one. We're going to draw a circle with any radius. My compass disappeared, so I got to pull it up again. Okay, here we are. Okay, so again, it's any radius here. Okay, so that's good. Okay, label these intersection points B and C. And we're going to draw circle B, any radius. Okay, so I'm going to pick up my compass. I'm just going to close this a little bit here. Pick up my compass, go to B. And draw a circle. So if I twirl this a bit, make it a little bit easier to see here. That's not quite working. I'll do it like this. Okay, if I put it here at B, and then I can open this up. Oops. Okay, so that's a good radius. Construct the circle. Or, a good arc. I'm going to do the same thing, so the same exact radius. I'm not changing any of the measurements. I'm just going to pick up my compass, go over to C, and construct an arc again. Same radius. So you can see that these two arcs are intersecting really at two spots, but this one right here. We can call that our intersection of D. So if we want to construct the angle bisector of this angle, I just have to do a ray from A through D, and there you go. I have split the angle up into two congruent angles. AD is then a bisector of BC. Okay, if I want to construct an equilateral triangle, if I want to construct an equilateral triangle, first of all, I'm going to need my compass, and I need to stop drawing rays here. Okay, if I want to construct an equilateral triangle, what I have to do is take my compass, twirl it around a little bit here, and I'm going to measure it, or open it up so that it's as far open as AB. So get this right here. Okay, so like that. That should be good. And we're going to construct a full circle here. I'm going to do the same exact thing, so I'm not changing the measurement. But now the center of my circle is going to be at B. Oopsies. Come on, pencil. Go. There we go. There you are. Now where the two intersection points, or where the two circles intersect, I should say, this point above it, really you could have picked the point below it. Let's call that point C. So if we want to continue constructing this triangle, do this in like red here, or and I'll use this line tool in red. I can go from A. Whoa, that's super thick. Okay, all I have to do then is join the triangle together using my line tool, or in your case, your straight edge. Okay, and there you go, equilateral triangle. Okay, constructing the perpendicular bisector. Just gotta grab my compass. Okay, constructing the perpendicular bisector. you're going to start at either A or B. In this case, it tells us A, and we're going to draw a circle with radius AB. Okay, and really you only need to be over halfway. AB's fine, but anything over halfway would work. So I'm going to construct an arc. Now keeping it the same, as in the measurement the same, I'm just going to now go over to B. Construct an arc again. Now it's important that you get these two intersection points, because now with my line tool, or with my straight edge, I'm going to join the two lines. Yeah, that's not the best. Apparently this is as good as it wants me to get. Okay, so closer. Okay, there's my perpendicular bisector that I just constructed. It is not only splitting this segment AB into two congruent segments by intersecting at the midpoint, it's also meeting the line at 90 degrees. So if we call this CD, segment CD is the perpendicular bisector of AB. Okay, in order to construct the incenter of a triangle, we have to construct the angle bisectors of at least two angles of the triangle. Okay, so we already previously talked about how to do angle bisectors, so I'm just going to go through doing the angle bisectors of any two of these, so maybe B and C. Okay, so grabbing my compass, okay, I'm just constructing an arc of any radius. And now I'm going to do two circles, both at these intersections, with two arcs. You can see where they intersect. So I'm going to draw a line. Okay, so there's one angle bisector done. I have successfully bisected angle ABC. Okay, now it doesn't matter, I can do A or C. I guess I'll go over to C. Okay, you see the intersection. Draw another line. Again, we're using our straight edge every time. I'm using a line tool here. So it is a nice straight line. Oops, that's not good. Okay, so like that. So where they intersect, this point right in here, that is our incenter. Okay, circumcenter of a triangle is made up of the perpendicular bisectors of at least two sides. So similar to the incenter, but different construction. So I just need to do the perpendicular bisector of any two sides of this triangle. I'll do the construction marks in purple. Okay, so I can take my compass, open up over half, or open up really over halfway on my segment here, BC. And I'm going to construct an arc. Now I'm going to do the same thing on B. So I flip the compass around, construct an arc. Okay, so now I have my two intersections, so I can construct a line between them. Now I'm going to do the same thing on really either of these sides here, so I'll just do AB. Looks like I have a little room over here. Okay, you really just need to be over halfway. Make your two marks, or your two arcs. Same thing on the other side. Okay, I've got the two intersections, so now I'm going to do my line. Okay, so where the two perpendicular bisectors are intersecting, seeing it right in here, that point that they have intersected at is what we call the circumcenter. Okay, so construct a line parallel to a given line through a point not on the line. Okay, we have a few methods to do this. First one is the converse of the corresponding angles postulate. Okay, so we're going to do this on the left here. We have our line AB. We're going to draw a line AC. Okay, we'll say there's really no point here for C. I'll say that's the point that I'm going through. There we go. Okay, so we'll say that that's C. This is my line then, AC. We're going to draw a circle, any radius, and label the intersection points D on AC and E on AB. Okay, so pulling up my compass again. Okay, so any radius. So it's intersecting both this ray that I constructed in this line. Oops. Okay, so I'm going to pick up my compass at after these two intersections, and I'm going to move the compass up to where point C is. And I'm going to create the same arc, even a little bit bigger. I'm going to go back to this intersection and put the pointy part of my compass there. And I'm going to measure how far open this angle is. And make a copy mark, which is very important that you make the copy mark. Pick my compass up. Notice I haven't changed the setting. Put it right at that intersection up here. Make another arc. Now where these two arcs intersect, this is what it's telling you to label your corresponding part as G. So now between C and G, I can make a line. Looks like my line tool doesn't like me. I gotta move it down a little bit. Alright. There we go. Okay, so what we've done is we've created two congruent angles. We've copied this angle up here, and because these two angles are congruent, we know that we've created corresponding angles congruent, so these two lines must be parallel by construction. Okay, I have these two letters here, A, and say I want to construct a line of reflection between the figure and its image. So we can tell that the line would be like somewhere right in there, right? But we have to actually construct it. So the first thing we do is we join the image and its pre-image. Okay, now in this case we don't really know which one's which, but we have to join it at corresponding parts. So using a straight edge, join them together. And what you're going to end up doing is constructing the perpendicular bisector of this segment, which we've already done before a few times now at this point. So grab my compass. Oops. Okay, green is a good color as any. Opening up over halfway, and I'm going to construct an arc. I'm going to do the same thing. I have not changed the measurement at all. Do the same thing on the other side. Alright, so where these two intersect, that's where we're going to draw our line. Okay, so through those two intersections, this line that I've created is the line of reflection that maps A to A. And that's what the steps are saying down here. Okay, if we want to reflect a line, or reflect a point in a line, you can see the steps down here. With my compass, which I should probably grab from up here, okay, so if we wanted to reflect a point P in line K, we have our steps 1 through 5 down here. I'm going to start by drawing a circle any radius so that it intersects the line K in specifically 2 points. So you'll see something like that. Where they intersect, those are what they're referring to as A and B. We're going to draw circles CA and CB so that they have the same radius from the intersection back to the point P. So I haven't changed my setting at all, so this actually is going to be the same radius. See that? Okay, so there's the arc. I'm going to do the same thing with this intersection over here. Okay, so where they have intersected, this right in here, this is what we call P prime. We're going to use then the reflection idea, and we're going to reflect now, instead of just a point, really 3 points that'll form a triangle. So the process starts off the same. Okay, grab your compass, start at one of the points here, open it up a bit here, and you're constructing a circle any radius because you just needed to hit this twice. And there you have it. Now, I'm not changing the setting. I'm picking it up, putting it right there, right at the intersection, and making another arc. And I'm going to do the same exact thing on the other side, this other intersection here. Okay, so where they have intersected, you can see this point right in here. Even looks like it's the same distance from the line. If we called this, say, A, this would be our A prime. Okay, and I'm going to repeat the process, and you'll watch me do it, for the next points, which I'll label B and C. Okay, once I had reflected all of the vertices over of this triangle, respectively called them A prime, B prime, and C prime, I just joined them together. This is my triangle that's been reflected. And it looks like it is the same size as the one that I started with, and it's just simply been flipped over this line, or reflected over. Okay, if I want to rotate a point P 60 degrees about point Q, 60 degrees is a positive angle, or positive rotation. So that means my point P is going to go in the counterclockwise direction. In order to do this construction, the first thing I'm going to do is construct the line PQ. So just like so. Using my compass, I'm going to go and put the pointy part at Q. So this is my center of rotation because I'm rotating about Q, and I have it opened up as far as P. I'm going to construct an arc in this counterclockwise direction. So like so. I'm going to pick up my compass, not having changed my setting, and I'm going to the point that I'm now trying to rotate. I make an arc. You can see this looks exactly like our equilateral triangle construction. Now, in an equilateral triangle, each angle is 60 degrees. So what's happened is this point has been rotated, now 60 degrees, and its new location is at this intersection point right here, which we'll label P prime. If, say, I wanted to rotate it 120 degrees, I could just go back to where I left off here, because remember I rotated it from P to here to get P prime. This was 60. I haven't changed the setting. All I have to do is construct another arc. That's another 60 degrees, and this would end up being 120 degrees because it's twice the 60, and I could just keep going around this way. And the next thing I'm going to do is translate the point P along the radius, or along the vector AB. First, going to measure how long the vector is. From A to the tip of B as best as I really can with this online tool here. Now I'm trying to go to the tip of the arrow. It's about as good as it's going to get. And I'm copying the distance. Now what I'm going to do is go back to P and create an arc in the same direction as the vector. So just like so. So what I've essentially done is copy the distance that the point P has to move. So my resulting P prime will end up somewhere on this arc. Next, I'm going to go back to the starting point of the vector. So back to A. And I'm going to measure from A to P. And make an arc. There's my little copy mark. And I'm going to pick up my compass, go back to B, and make an arc again. So where I have ended up, where this intersection happened, that is P prime. Okay, so just to draw in for you to get an idea of what this looks like. From P to P prime, this is the vector it moved along. It looks parallel to the original vector that I was translating along. Additionally, if I were to pick this up and just map it over the other one, they're about congruent, as they should be by construction. Okay, so that's how I translate one point. If we want to translate the triangle now along a vector AB, it always starts off the same. You're always starting with the length of the vector. Now the first point I'm going to translate is point P. So by keeping this the same, the first construction I'm really doing is helping me get the distance right that I'm going to be traveling. So the point that will end up being P prime will be somewhere on this arc. Okay, now I'm going to go back to the ray, or back to the vector. And I'm going to measure from A to the point I'm trying to translate. And make a copy mark. Now I'm going to keep the compass the same, pick it up, go to B, and make another arc. Now I said that P prime would end up being on this arc. I measured then the distance from A to P, made a copy mark, copied that from B to this arc. So where it intersects, that's our P prime. Okay, and I would do the same thing with Q and R and end up with a triangle. So keep watching to see how the rest of this turns out. Okay, so I actually got 2 of the points. Unfortunately, it looks like my compass will not reach point R. Struggles with technology. But you got the idea of the 2 of them. Just do the same thing with third. It'll end up on this red arc that I've created, likely somewhere like right in here, and it should look like the triangle is congruent to the original one, just been moved down. Okay, we're going to take this triangle centered with the center of dilation of P, which is on the triangle, and we're going to make it 2 times bigger, so dilating it by a scale factor of 2. First thing we're going to do is draw rays PR and PQ. So using your straight edge. Now, in order to copy this, to make it twice as large, we're going to use our copy construction. So going back to P, I'm going to open up my compass as far open as PQ, just like so, and make a copy mark. So this is the distance that I'm going to copy. Just pick up your compass and move it over where you left off and make another mark. That's what ends up being now Q prime. Okay, we're going to do the same thing with PR. Once we have those, we can construct the rest of the triangle. So join RQ and Q prime, or R prime and Q prime, I should say. And there you have it. Now, P prime, since it's at the center of dilation, remains in the same spot. P is the center of dilation, so P prime is technically in the same exact spot. So P prime, R prime, Q prime, twice the size as the original figure. Okay, so now we're going to dilate it where the center is not on the triangle, but rather it's off the triangle. So what we need to do is construct rays from the center of dilation through each of these vertices. Now using our compass, we're going to do the same thing, or same idea, where we're going to open it up. So I'm going to turn this all the way around here. Open it up so that I'm measuring from O to P. So right in there, and we're going to make a copy mark. So I'm going to copy the distance essentially from O to P, and if I want this to be twice as large, I got to copy the segment twice. And I'm going to do the same thing for each of these. So O to Q. I'm going to copy it twice. And O to R. I don't like that one. Okay, now where each of these ended up, this is now P prime. This out here is Q prime. And lastly, this is R prime. So our triangle, when I join it all together, looks like this. Okay, so our triangle that I've created now is twice the length of, or twice the size of the original figure that I had here. I've just doubled the lengths of all of the sides. Okay, if say I wanted to make it 3 times as large, I would just have to copy each of these segments in here. I'd have to copy this 3 times, and then my resulting triangle would be 3 times as large as the original triangle. Lastly, in this video, we're going to go through dividing a segment into congruent segments. So in this case, we're going to do 5 congruent segments of AB, or breaking up AB into 5 congruent segments. So the first thing we're going to do is start from A and just draw a nice long line. I'm going to take this line and, using my compass, break it up into 5 congruent segments. So you go to A, and you're going to want to open up your compass as whatever radius you want. So just a smidge like that. So that should be good. Okay, so I just need to fit 5 of these segments here. So I just picked a radius, something like this. I'm really just using it to section off 5 parts. So 1, 2, 3, 4, and lastly 5. Okay, I'm going to label each of these points A, B, C, and D, and this is really important because there's going to be a lot of stuff going on in here that you need to keep track of. And using the letters will be helpful. Now I'm going to complete a triangle by drawing now E to B. Now my next step is essentially copying this angle up here, E, at each of these segments, or each of these little points in here. Oh, I just realized I probably should. So I'll just rename these. 1 second. We will say C, D, E, F, G. Okay, now we're all good. No letters are reused. Okay, so now we're going to copy angle G at F, E, D, and C. Okay, so I'm just going to change the color here to make it a little bit more obvious. So I'm going to take my compass, go to G, and I'm just going to close this a little bit. I'm just going to make an arc so that it intersects both of these sides of the triangle here. So just like so. See how it's intersecting both of those sides of the triangle. And I'm going to pick up my compass and do the same thing at F, constructing an arc about the same size. So at F, at E, oops, don't want to change my setting, D, and lastly at C. Okay, so now I'm going to go back and I have to go to F, or not F, the point right above F, that intersection, and measure from F to this intersection in here where it's hitting side GB. So just like so, and I'm going to make a copy mark. I'm going to do this on each of the purple intersections that you're seeing, so the ones that don't have letters along the line segment. Oops. Okay, there you are. So now using my straight tool, or my straight edge tool here, G is already on a line with B. The next line I'm going to create that's going to end up being parallel to G is from F through this purple and yellow intersection, all the way to this line segment AB. I'm going to do the same thing at each of the other letters. So E through this purple and yellow intersection, D, and lastly, C. Okay, so each of these line segments, because I copied essentially a bunch of corresponding angles and they're all congruent, I've created a bunch of parallel lines. So by doing so, each of these segments is now congruent. So I have taken segment AB and broken up into 1, 2, 3, 4, 5 congruent segments. Lastly, what we're going to do is find the center of rotation between these two lightning bolts. You can see that it looks like one lightning bolt has or could be mapped onto the other by a rotation, probably with the center about in here. What we're going to do this is create a segment joining two corresponding vertices, so just like that. And we're going to do the perpendicular bisector of this segment that we've just constructed. Okay, there's one perpendicular bisector. Now we're going to go ahead and do one more. So that means we need to join another set of corresponding vertices. Now notice that this segment that I chose does not look parallel to the first one that I chose. If they look parallel, construction's not really going to work. Okay, perpendicular bisector again. Do this in a different color. Okay, so where you see the two perpendicular bisectors of these two segments that I drew intersect, you can see they go right there, which is where I anticipated the center of rotation would be about. Okay, and it even looks like this lightning bolt could do a clockwise rotation that would map this one onto its image, or even vice versa, could go the other way from this one to this one. Okay, so there we go, we found it.